Hi there, welcome to Math 40. We're going to be continuing our lecture from Lecture Notes Week 8. So this is page 11. I encourage you to have a blank sheet so that you can follow along with what we're going to write on these next few pages. Okay, so before I even begin, I just want to alert you to the typo. On the table here, there is a 4 missing. We're going to be graphing y equals 4 times cosine of 4 over 3x, but there is no 4 there. So please make sure that you replace this with y equals 4 times cosine of 4/3 x. All right. So for the first time, we're going to be taking a look at change in amplitude and change in period together happening at the same time. So as you can see, the table is completely blank. No x values have been given to us. We are tasked with finding what are the important x values that are going to correspond to the highest point of the graph and the lowest point of the graph, as well as the zeros. So we're going to learn how to do that in the next few examples. And in order to get started, I want us to take a first step of finding the period. Now the period, we devised a way to calculate it for every single instance of a sine or cosine function. And that was to take 2 pi and divide it by the number of cycles, which we call b. And b is the coefficient of x always, which is this 4/3. So we have the period is 2 pi over 4/3, which is going to be a 2 pi over 1 times 3 over 4, because we're simply multiplying by the reciprocal of 4/3. Okay, so that's going to give us a 6 pi over 4, which if we divide top and bottom by 2, is going to give us a 3 pi over 2. So we have a period of 3 pi over 2. That's the first step. The next step is to find the step size. And when I say find the step size, I mean find what is the difference between each x value. And if you recall from last week's lecture, in order to find out where the peaks happen or the zeros happen, or the lowest points of the graph happen, they happen at every quarter of the cycle. So what we're going to do is we're going to take the period and divide by 4, because the period defines where one cycle is completed. That means that we're going to take that distance and divide by 4. Okay, so that means taking a 3 pi over 2 divided by 4. Remember, division is multiplication by reciprocal. So we're going to take the 3 pi over 2, multiply by the reciprocal of 4, which is 1/4. And that'll give us a 3 pi over 8. Okay, now to find the x values, that would be our next step. We always start at 0, so x0 is going to be 0. And then the next x values, we simply take the step size and keep adding it to the previous x value. Or sometimes an easier way to think about it is to simply take the 3 pi over 8 and multiply by whatever the subscript of the x value is. So to find x1, we take 1 times 3 pi over 8, which is 3 pi over 8. And that is the same thing as taking 0 and adding the step size. Okay, for the next one, we're going to take 2 times 3 pi over 8, because we're adding 2 of those, right? We're adding 2 of those to 0, or if you want to think about it, is adding 3 pi over 8 to 3 pi over 8, which is just 2 times that amount. And that's going to give us a 6 pi over 8, which when we reduce by 2 top and bottom is going to give us a 3 pi over 4. Right, the next x value will be given by a 3 times 3 pi over 8. And that'll be a 9 pi over 8. because this is like a 3 over 1. And finally, x4, that's going to be basically the last quarter, right? This is the first quarter, second quarter, third quarter, last quarter. 4 times 3 pi over 8, that's going to give us a 12 pi over 8, which when you reduce by a 4 will give you a 3 pi over 2. And notice here the last x value is agreeing with the period, and that's usually a good sign. That means that we're on the right track because we are trying to complete one cycle and finding the quarter of the cycle. So these are all the quarters, and the last quarter should agree with one full cycle, which is given by the period. Right, so now that we have these x values, go ahead and transfer them over to the table the way that I have here. Because the next step will be to find the corresponding y values to these x values. So let me just write that down. Step number 4 is to plug the x values into the equation to obtain the corresponding y values. Okay, so for the first one, we're going to have y equals 4 times cosine of 4 over 3 times 0. That is a 4 times cosine of 0. And cosine of 0 is simply 1. So we're going to get a 4 times 1. Okay, so that's just a 4. That means the first point would be a 0, 4. Now, if you take a look at the graph, we're not going to have enough room to plot a 0, 4. So what I'm going to do is I'm going to relabel these tick marks so that they, so that this tick mark instead of being 1 is a 2, and then the 2 would be a 4. Same thing going into the negatives, there'll be -2, and this will be -4. That means that 0, 4 is going to be up here. Okay, next x value, we're going to get 4 times cosine of 4/3 times a 3 pi over 8. The 3's are going to cancel, and it's going to give us 4 times cosine of 4 times pi, that's 4 pi, over 8. So 4 pi over 8. But that's going to reduce down to a pi over 2. Now cosine of pi over 2 is 1, so we end up with a 4 times 1. And that means that we have the point 3 pi over 8, comma, this cosine of pi over 2 is 0. So we're going to get a 4 times a 0, which is simply a 0. Okay. Now, as you can tell, we don't have intervals of pi over 8. That means that we are going to have to try and find where those should be marked. Now, what's going to aid us is a little trick that we've been learning in the past couple weeks, and that is that if we take pi over 2 and divide by half, then we're going to get a pi over 4. And then if we take pi over 4 and divide by half, we're going to get a pi over 8. So these are just intervals, or these now are incrementing in pi over 8. This would be 1 pi over 8. This would be a 2 pi over 8. This next one would be a 3 pi over 8, which I'll write here. Next would be 4 pi over 8, but it reduces down to a pi over 2. That means that this would be a 5 pi over 8, followed by a 6 pi over 8, but 6 pi over 8 will reduce down to a 3 pi over 4. Then we'll have 7 pi over 8, 8 pi over 8, 9 pi over 8, 10 pi over 8, but that reduces down to a 5 pi over 4. 11 pi over 8, and finally 12 pi over 8 that reduces down to a 3 pi over 2. And I say finally because if you notice that is the last x value that we're going to be plotting, so I don't need to go beyond the 3 pi over 2. So we'll stop there, and now we'll go ahead and plot. 3 pi over 8 comma 0 would be here. And that means we can go on to the next x value now. That'll be 4 times cosine of 4 over 3 times 3 pi over 4. The 3's are going to cancel, the 4's are going to cancel, and we're going to have a 4 times cosine of pi. Now cosine of pi is -1, so we're going to have 4 times -1, which is going to give us a -4. So the point that we're looking at is then 3 pi over 4 comma -4. Okay, so 3 pi over 4 is here, -4 is down here. That means that that is our point. Alright, y equals 4 times cosine 4 over 3 times 9 pi over 8. This is going to become a 4 times cosine of, the 4 and the 8 are going to reduce down to a 2, and the 3 and the 9 are going to reduce down to a 3. So we'll end up with a 3 pi over 2. Now cosine of 3 pi over 2, that's 0. So 4 times 0 will be, in the end, 0. That means we have 9 pi over 8, comma 0. Okay, here is 9 pi over 8, and 0 means we stay on the x-axis. Last one is 4 times cosine of 4/3 times a 3 pi over 2. That means that we have a 4 times cosine of 3's cancel, 4 divided by 2 is 2, so we get 2 pi, and cosine of 2 pi is 1. So we get a 4 times 1, and that is 3 pi over 2, comma 4. Okay, so here is 3 pi over 2, comma 4. And so finally the last part would simply be to graph according to these points, to use these points as a guide for the shape of the graph. So for cosine, we know that we start up at the top and then pass through 0 and then curve, go down to the lowest point, which in this case is this -4, then curve and come back up, pass through 0, and continue on to the highest point of the graph. Okay. So that's what the shape roughly looks like. If we look at the characteristics relative to the original equation, the 4 in front of the cosine tells us that the amplitude we should have been expecting was an amplitude of 4, right? And because that coefficient of cosine is positive, we do not expect a reflection about the x-axis. And so that's exactly what we're noticing with the graph. We're starting at 4, which is the way by the way, how cosine starts its graph. It always starts on some positive y value and then continues to go down. And if you check out the amplitude, well, the distance between the highest and lowest point is 8 units, right? So half of that is going to be only 4 units. So our amplitude here is 4, which agrees with what we're seeing for the coefficient of cosine. Now the 4/3 is dictating what the period is going to be. And this is telling us that in 2 pi radians, we're going to see 4/3 of a cycle. So what that means is we're going to see 1 full cycle plus 1/3 more, because 4/3 is the same thing as 1 1/3, right? So that means that in 2 pi radians, we should see 1 full cycle, and if we continue the graph, we're going to see a third of another one. Okay. Which it's a little difficult to draw, but you can see that there is this complete one cycle, and then this chunk between 3 pi over 2 and 2 pi is going to contain what seems to be a third more. Okay. So that is first example that has change in both amplitude and period. Alright, example number 2 is a bit interesting because we see again a change in the amplitude. We still have a coefficient of 4 cosine, so we can be expecting an amplitude of 4 without any reflection. But now if we take a look at the coefficient of x, which determines the period, we see that negative coefficient. So we want to, again, not deal with negative coefficients of x. That's something that we briefly discussed last week. And in order to get rid of that negative, we're going to use the symmetry of cosine. Because cosine is even, that means that this negative can be absorbed, or in other words, we can just ignore it and say that y is equal to 4 times cosine of 2/3 x, because these two are going to be equivalent. The y values are going to be equivalent for every x value. So we can just simply deal with graphing this instead of the negative 2/3. Alright, so if we go through that series of steps that we were looking at for the previous example, the first step is to find the period. And the period is 2 pi divided by b, where b again is the number of cycles, or on the equation, it's going to be the coefficient of x. So we're going to get a 2 pi over 2/3, which is the same thing as a 2 pi over 1 times a 3 over 2, multiplying by the reciprocal. And that means that the period is going to be, well, 2's are going to cancel out, a pi times 3, which is going to give us a 3 pi. Okay, the next step is to find our step size. So the step size, as we saw in the first example, is going to be the period divided by 4. So that is going to be a 3 pi, actually I think it fits here, 3 pi over 4. Okay, next step. Well, next step is to find the x values, starting with x0 being 0. Okay, then x1 we can find by taking the step size and multiplying by 1. So 1 times 3 pi over 4, which is just 3 pi over 4. Then x2 is going to be a 2 times 3 pi over 4, which is going to be a 6 pi over 4. And if we reduce by a 2, top and bottom, we're going to get a 3 pi over 2. Next one is going to be 3 times 3 pi over 4, which is a 9 pi over 4. And last one, 4 times a 3 pi over 4. The 4's are going to cancel, giving us a 3 pi. Okay, so we'll transfer over those values. We'll have 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. These are all the quarters of the cycle. Notice the cycle is completed in 3 pi radians. So if we divide that by 4, we're getting the quarters of the cycle. And now what we have to do is take those values and plug them into the equation. So just to make our work go by a little bit faster, I'm going to rely on my calculator to do this, because that way I can just simply go ahead and do second ands and change my x value. First thing that I'm going to do is make sure that I switch to radians, and then we can start plugging in. So the first would be 4 times cosine of negative 2/3, and I'll make sure to include some parentheses in here. So negative 2/3 times 0, which is simply 4. Notice that makes sense because negative 2/3 times 0 is 0, cosine of 0 is 1, 4 times 1 is 4. Okay, next value. Notice I'm doing simply second, enter, so that I can get my previous expression. On your calculator, you can just experiment with where this keyword entry is at, so that it can bring up the previous expression. For some calculators, you can just press the up button, and that'll automatically bring it down for you. Alright, so we're going to be replacing the 0 now with 3 pi over 4, right? Because we want negative 2/3 times 3 pi over 4. So I'll include some parentheses in here, and then have 3 pi over 4. Make sure I'll eliminate that 0, and then I'm going to be missing one closing parenthesis. So that we get 0. Okay, repeat it. But now it's a 3 pi over 2 for the next value. So instead of having 3 pi over 4, we'll have 3 pi over 2. We get negative 4. Okay, then the next one is 9 pi over 4. Okay, so I've got 9 pi over 4. That gives us a 0. And finally, we're just going to have 3 pi. So I'll change this to 3. And we get a 4. And notice these values are not kind of a surprise to us. We chose the x value so that it would give us the highest point, lowest point, and zeros. So the fact that they're coming up nicely this way is a good sign. Alright, so let's see. We're going to need intervals that accommodate for 3 pi over 4, or tick marks that accommodate for 3 pi over 4, 3 pi over 2, and 9 pi over 4. So what I'm going to do is I'm going to take, let's say like 3 pi, draw it somewhere, and divide that interval into 4 equal parts. So this is 1, 2, 3, 4. That'll be my 3 pi. And then half of 3 pi would be 3 pi over 2, so that would be this here. And then half of 3 pi over 2 is going to be 3 pi over 4. And simply what I'm doing there is I'm doing 3 pi over 2 divided by 2, which is 3 pi over 2 times 1/2, which is 3 pi over 4. Okay, that's all the magic that's happening there. Okay, and then if I take a 3 pi over 4, which is the size of this interval, and add it to a 3 pi over 2, I'm going to get a 9 pi over 4. You can verify that on the side again. So if I take a 3 pi over 2 and add a 3 pi over 4, okay, so I'm simply taking the size of this interval and placing it here. So that means taking the 3 pi over 2 and adding this piece, which measures 3 pi over 4. We just want to verify that it really does give us this 9 pi over 4. So this one here, we would need to multiply top and bottom by a 2 in order to have the same denominator. And that would give us a 6 pi over 4 plus a 3 pi over 4. And then adding those two together gives you the 9 pi over 4. And how did I know how to do that? Well, I know that the full cycle happens in 3 pi radians, and when I took that and divided it into 4 equal parts, it gave me 3 pi over 4. So that's essentially the same thing I did, but now on the graph. Take 3 pi and divide it into 4 equal parts, and you'll get these x values. Okay, we're going to be graphing the cycle then. I'll just erase these so they don't get in the way. the highest point is going to be a 4, the lowest point is going to be a -4. So when we draw our tick marks, we want to make sure that we can fit in those values. That means that I'll make this the 2 and this a 4. So at 0 we get a 4, at 3 pi over 4 we get 0, at 3 pi over 2 we get -4, at 9 pi over 4 we get 0, and at 3 pi we get 4. That means that we complete one cycle in this manner. Alright. Now this is supposed to extend all the way down to 15 pi over 4 in the positive direction and to -15 pi over 4 in the negative direction. So we have to figure out where those are. Let's see if we can, kind of figure it out. Well, we said the size of in between the interval is 3 pi over 4. So if I add a 3 pi over 4 here, okay, so if I do this, this is essentially going to become a 12 pi over 4 plus a 3 pi over 4, right? Just rewriting it so I have the same denominator. And that's going to give me a 15 pi over 4. Okay, so that means we only have to extend it to one more tick mark to the right. So that means that we would have, if you punch it into the calculator, there are two things. The first one is we can have an educated guess as to what's going to happen at 15 pi over 4. And well, since these two are equally spaced apart, we can guesstimate that this is going to be, it's going to go down to 0. But we can always verify it by punching it into the calculator. So instead of having this 9 pi over 4, I'm going to replace that with a 15 pi over 4. Okay, now this is giving me a funky answer. This is saying -8 times 10 to the -13. That's because with calculators, they always represent numbers to a nearest decimal place. So this is actually a very, very, very small number, very close to 0. When I say very small number, I mean very close to 0. So it's probably best that we just kind of verify by hand because the calculator is not being too helpful at this point. But if we plug that into this equation, we're going to get y equals 4 times cosine of -2/3 times 15 pi over 4. And that's going to be a 4 times cosine of the 2 and the 4 are going to simplify to a 2. The 3 and the 5 are going to simplify to a 5. So we get -5 pi over 2. And if we look at what is cosine of -5 pi over 2, that's going to be 0. So we're going to get a 4 times a 0, which is simply 0. Okay, so that confirms our suspicions that a 15 pi over 4, we're going to go down to 0. Okay, what do we do beyond that? Because we still need to extend to -15 pi over 4. Well, first things first, let's just go ahead and label the tick marks. Okay, so 1, 2, 3, and 4. This is going to be -3 pi. This is going to be -3 pi over 2. This will be -3 pi over 4. And this will be -9 pi over 4. And I'm quickly getting these values simply by reflecting them over, right? If 3 pi over 4 is -3 pi over 4 is a reflection of 3 pi over 4. Then 3 pi over 2 and -3 pi over 2, well, those have the same distance for 0. Same is true about these last tick marks. All the way down to -15 pi over 4. Okay, then what? Well, then we remember the symmetry of cosine. Cosine, we said, is an even function, and any even function reflects about the y-axis, meaning there are mirror images, the left-hand side and the right-hand side. So if we use this as a mirror, that means that the 3 pi over 4 comma 0 is going to reflect to negative 3 pi over 4 comma 0. The 3 pi over 2 comma negative 4 is going to reflect over to negative 3 pi over 2 comma negative 4. Oh, and I think I probably mislabeled this point. This one should have been here. And there. Okay, that's better. Alright, then 9 pi over 4. At 9 pi over 4 we have 0. That means at negative 9 pi over 4 we'll have 0. And then at 3 pi we have 4. That means at negative 3 pi we're going to have 4. And negative 15 pi over 4 will be a reflection of 15 pi over 4. So it'll also have a y value of 0. So we're going to see the graph oscillate in the same manner that it did for the positive x values. Yeah, so that's what we get. Let's check the attributes now. Does it have an amplitude of 4? Well, highest value is 4, lowest value is negative 4. The distance between these is 8. Half of that is 4. So, yep, it still has that amplitude of 4 with no reflection about the x-axis, right? It started on the positive y-axis, not on the negative. So that looks good. And then the period, we found it to be 3 pi. So period is 3 pi. Does that agree with what we saw here for B? Well, for B, it says, well, you're only going to be completing, if we're looking at the positive version of it, you're only going to be completing 2/3 of the cycle in 2 pi radians. So what that means is that you're going to have to take a little bit longer, you're going to have to take more than 2 pi radians in order to see the full cycle, meaning the period has to extend. And that's exactly what's happening here. We see the period extend beyond 2 pi into 3 pi. Okay, so all is in agreement. For one last example, example 3, we have to graph y equals 2 times sine of negative pi x for x being between negative 3 and 3. So again, we have that negative coefficient for x. We're going to use the symmetry of sine. Now, if you recall, sine is an odd function. And unlike in an even function, we simply can't ignore the negative, or we can't absorb the negative away. For an odd function, what that means is if you have an f of negative x, you bring out the negative in front of the function. So it's negative f of x. Okay, so applying that to what we have here, that means that we're going to end up with y is equal to a negative 2 times sine of pi x. So I'm bringing out the negative to the front, but there is that 2, so I need to make sure that I bring it all the way outside. So think of it kind of like a negative times a positive 2 gives us a negative 2. And now this is the function for which we're going to be finding the period. Okay, so here's step 1. The period is 2 pi over b, where b again is the number of cycles or the coefficient in front of x. So we have a 2 pi over pi. That means that the pi's cancel and we get a 2. The next step is to find the step size. And the step size is going to be the period over 4. That means that we have a 2 over 4 for a final step size of 1/2. Alright, so now we need to find the x values, starting with x0 being 0. Okay, the next x value will be given by 1 times the step size, so 1 times 1/2, which is just 1/2. Next x value will be 2 times 1/2, which is simply 1. Next x value will be 3 times 1/2, or 3/2. Last x value will be 4 times 1/2, which is going to give us a 2. Okay, so we're finding all of the quarters of the period. If the period is 2 and you divide it by 4, you're going to get each quarter happening at multiples of 1/2. Okay. Alright, so now we're going to transfer those over. We're going to have 0, 1/2, 1, 3/2, and 2. And we're going to plug those into our equation to see what corresponding y values we get. Okay, so the first one is 2 times sine of negative pi times 0. So we get 0. Okay, then we have negative pi times 1/2. I'll go ahead and introduce the parentheses here, in which case we no longer need this times. I mean, we can leave it there, it doesn't hurt. Okay, and we're going to get negative 2. Alright, next one is 1. So I'm just going to delete the 1/2 and get 0. Next one is 3/2. We get 2. Next one is 2. We get 0. Okay, so let's plot these on our graph now. We need to make sure that we have all the way up to 3. So let's see, and that we can draw all of the half intervals. So if we make this, let's see, 1, this would be 2, and then we would have 3 here at the end. Then this would be 1/2, 3/2, and 5/2. And same thing going in the negative direction. We'll have -1, -2, -3. This will be -1/2, -3/2, -5/2. And let's see, lowest point is -2, highest point is 2, so we can make this 1, 2, and then -1, -2. And now we have all the tick marks that are needed. Let's plot the points. We got 0, 0, 1/2, comma, -2, so that's down here. 1, 0, 3/2, comma 2, 2, 0, and if we continue the pattern here, well, let's see, at the next quarter, this is already completed one cycle, so we're going to start repeating. We're going to go down to -2 and then back up to 0 to get this shape of the graph on the positive x-axis. Okay, now we continue into the negative x-axis, into the negative x values. If it already completed a cycle between 0 and 2, that means that going into the negatives, we're going to start repeating some values. So this is going to go up to a +2, then down to 0 at -1, down all the way down, down all the way to -2 at -3/2, up to 0 at -2, up to 2 at -5/2, and down to 0 at -3. And here I'm just simply using the pattern of the graph. I know that it's oscillating back and forth between 2 and -2, but you could always verify what the y values truly are by taking the x value and plugging it into the equation. Like for instance, let's say that I wanted to verify that at -1/2 we go up to 2. Well, then we can simply plug it in. Okay, I'm going to replace that 3/2 with a -1/2. And we see that we go up to 2. Okay, so that verifies that. Let's say that I want to verify the -1 now. Well, what I could do is simply delete the divided by 1/2. we get the 0. Okay, so all those y values you can verify by plugging them into your equation. Once you are satisfied with that and convinced, you can start drawing the shape of the graph. Okay, so again, let's take a look at what we were expecting simply by looking at the coefficients of the equation versus what we have on the graph. So once we took into consideration the symmetry of the function and we said, okay, this equation is equivalent to this one here, we now have a coefficient of -2 for sine. So that means two things, right? Last week we learned the negative causes the graph to reflect about the x-axis. So sine normally begins going up and then coming down. This one begins going down and then going up, which is a sign of reflection, which means that it is consistent with that negative being there. The other change we saw from the original sine graph is that we have an amplitude of 2. And well, again, if you look at the difference between the highest point, which is 2, and the lowest point, which is -2, that's a distance of 4. Take half of that and you get 2. So the amplitude is consistent with what we see in the coefficient. All right, what about the period? Well, the period was 2 pi, would originally be 2 pi, but because of the pi, we divided 2 pi by 2 to get a period of 2, and well, that's what we're seeing on the graph as well. And one cycle of sine gets fully completed between 0 and 2, and then if you want to continue the graph, you'll see a repetition of it after the 2, or if you decide to go into the negatives, you'll see a repetition of this portion of the graph happening between 0 and -1/2. Okay, so in any case, we see that the period will indeed be consistent with 2.